record on this computer. All right, welcome back, Algebra Express. We are in Rockswold 6.4. We're doing the first part of this, and we are introducing matrices in this section. So in this section, we're going to find solutions to linear systems using matrices. That's what the title is. And so we want to first talk about what a matrix is. Make a whole bunch of horrible Neo and Morpheus references, but I guess I'll wait till a little bit later. So the definition of a matrix is a two-dimensional array of numbers. So we have rows and we have columns. So I have a hard time thinking about that. So rows are like theater rows. They go across this way. Columns are like the things that hold up the buildings. They go up and down. So we talk about this thing rows by columns. So if we're going number of rows by number of columns, this has, what, 2 rows by 3 columns? So this is a 2 by 3 matrix is what we would say. And just when we talk about the dimensions of a matrix, we always go number of rows by number of columns. I made an RC Soda reference a couple years ago, and I don't think any of the students knew what RC Soda was, but it's out there. It's called Royal Crown. It's basically kind of like a cheap Coke, and I think that's why no one knows what it is. Okay, so we have a system of equations. We have been working with systems of equations. We have been working with 2 variable systems of equations. So when they have 2 variables, we typically had 2 equations, and we could solve these things for our solutions to those systems. And so if we look at this thing called a coefficient matrix, basically what happened, and you might want to notice these things are in standard form, right? They look like ax plus by plus c, they're equals c. So this is like ax plus by equals some kind of constant c. Let me just write it up here. Some constant over there, c, right? And so if they're not in this order and you want to throw them into a matrix, you might want to put them in that order first. And so what happens is we ended up doing a lot of operations with like systems of equations, or some old mathematician along the way did a bunch of stuff like this. I believe Cayley was the guy that was first operated on matrices. That was the guy. And he took these things, and he did a lot of operations, and he realized like the x's get added to the x's, the y's get added to the y's and stuff, and so it doesn't really matter that we have a x or y on which is the x and which one is the y. And so what he did is instead of writing the symbol, he used like placement to represent like these were the coefficients of the x's, these are the coefficients of the y's. Same thing over here. A coefficient matrix is just the coefficients off of this. We're almost never going to do this. We're almost always going to jump to the augmented, coefficient matrix. And so these are my x's, these are my y's, and this is the equals some kind of constant over here. And so if we go back and plug this in, this looks like 2x plus 3y is equal to 5, which is this first equation right here. Same thing with this. This is 1x minus 1y equals 0. That's what this equation looks like right here. And so we're not really doing anything different than what we've done previously. We're just using a different sort of notation to do it. And so everything that we've done with systems of equations, we can definitely do with matrices. So the rules that apply to systems of equations, they have sort of analogous sort of rules that exist within the matrix. So let's look. We can interchange 2 rows. Why can we do that? Because whether we write 2x plus 3y equals 5 first or x minus y equals 0 first, it doesn't matter. This system of equation is a system of equations, right? It doesn't matter which line we graph first. They're still going to intersect in the same kind of point, right? So it doesn't really matter which one we do first. We can interchange our equations. So I can swap rows, as this is saying. So I can interchange any two rows. I can multiply any row by a non-zero constant. So I'm going to ask you to go back in your brain and think about when we were doing like those elimination steps, right? When we did the elimination, if this was off by like what? Some number, we want to multiply, I guess, this equation by 3 would get rid of the y's. We can multiply everything here by 3. 3 times the x, 3 times the y, 3 times the 0. So each term, each coefficient, right, and each constant is going to get multiplied by the same number. So this is like when we're multiplying an entire equation. So minus 2 times 2 is 3 is minus 2 times 5. That's what I'm trying to say. Okay. We can change rows, we can multiply entire rows, and then the last thing we can do, that's kind of a mouthful the way that they phrase it, but there it is, add a constant multiple of any row to another row, replacing it in the matrix. That's what we're doing. So what we're doing is like when we did elimination steps, right? If we want to add this side to this side and we want to add that side to that side, that's not going to break the equality. We can still do that, right? And so we can do the same thing here. All we're doing is adding stuff down. So we want to do minus 2 times row 1 plus row 2. So if we look up here, we already have minus 2 times row 1. And we want to take this and we want to add it to this row and we want to replace it here. So minus 4 plus 1 is going to give me a minus 3, a minus 6, and a plus a minus 1 is going to, and I have minus 10, and I'm going to add that to 0. Okay, so now I hope you like pause the video just for a second and do this thing right quick. We want to do minus 3 times row 1 plus R2. So minus 3 times row 1, that out, minus the three numbers I'm looking at are minus 3, 6, 6, and I want to add that to row 2, which I'm adding these two things together, minus 3 and 3. And 6 and 5 should give me okay. So basically what we're kind of setting up here is we can flip rows up and down. We can do what, multiply entire rows and we can add rows. So these are going to look very similar, or they should look kind of similar to like the elimination process, right? Things that we were doing when we did elimination. So we're going to do all these steps, and we're going to do these steps to make the matrix look kind of pretty and to put it in a way that is easy, kind of easy to solve it. And so they throw this thing out you, Gaussian elimination with matrices. And so that is what we're doing. That is the process to get it to this form called the row echelon form. So the row echelon form, and echelon, if you're familiar with like vocabulary, it's used fairly widely in like military vocabulary, I know, and in marching vocabulary, it means a diagonal sort of formation. So echelon means like the diagonal. So what's happening is there's ones in the diagonal, and there's zeros below those ones. So there's ones in the diagonal, there's zeros below the ones. So you'll see the little tildes. Basically what that means is we don't care what that number is. It can be any number. Okay. And so, we want to start with an example. We have this system of equations. They put it into a matrix for us. This is a 2 by 2. They're handing that we're going to get to 3 by 3. We haven't talked about those yet. We haven't talked about what those equations look like or anything. So we're getting there. First, get a 1 in the upper left corner by swapping the rows. So the first thing they want you to do is swap the rows. So they're going to walk you through the row echelon form in this thing. Here's my suggestion for row echelon. We're going to get the 1, and then we're going to get the 0 below it. And then we're going to get the 1 here. Same thing here. You get the 1, and then you get the zeros below it. And that's the basic sort of approach that I'm going to take. I'm going to go left to right. I'm going to get the 1 and the zeros below it, and then we get the 1 and zeros below it. And so the first thing they do is they get a 1 in the upper left-hand corner. And so now that we get a 1 in the upper left-hand corner, you get a 1, and then you get the zeros below it. And so what happens is when we get a 1, it kind of works as a unit. So whatever this number is, this is a positive 2. We need to do the opposite, additive opposite. So the opposite of a positive 2 would be a negative 2. So we do negative 2 by this entire row, and we're going to add it to row 2. So I'm going to do that, and I'm going to do it all in one step now. I don't want to write those middle steps like I did in that previous one. So minus 2, row 1. Looks like minus 2 plus 2. Looks like minus 2 times minus 2 is 4. Plus 3 should give me 7. Minus 2 and a minus 5 is a positive 10. I add 4, and that should be 14. Now I'm looking at this. I have a minus 1, minus 2, minus 5. I have 0, 7, 14. I got a 1. I got the 0 below it. The next thing I do is I move over. I don't care what this first thing is. I want the 1. So to get the 1, they do 1/7. 1/7 multiplying by 1/7 is the same as dividing by 7, right? So 0 divided by anything is 0. By 7 divided by 7. Now we want to read this thing off. So going back, and these were my x's, these were my y's, right? They were the same throughout the whole thing. Hope I don't have to write it throughout the whole thing. So this first thing is telling me x minus 2y equals minus 5. This next one is telling me I have 0 x's. So you can write 0x there. If you don't want to write it, you don't have to write it. So 0x plus 1. So this is nothing else than right? So what is this giving me? This is giving me y equals 2. So I have y, I have the system of equations, and if I put it in this row echelon form, you might notice this thing is already solved for. This thing is almost already solved for. I got to do a little bit of work, but not a whole lot. I'm going to plug my y back in. Let's look at x minus. And if we add the 4 over, x is a minus 1. There we go. And so if I wanted to put it all together, this thing should look like an ordered pair. X comma y, right? So I'm going to give you like a little warning on these things. They're going to take a bit of paper. This section will take a bit of paper. The next section, hopefully, we'll talk about when we get there. But I don't think it'll take as much paper. If that makes up for things. Okay, so we know about systems of equations. We can put the system of equation into this crazy thing called a matrix. We can do that row echelon form by getting 1 and getting zeros below it. And the row echelon form spits us out things that look a little prettier to solve. And then once we do that, we can plug things back in and solve fairly easily. And so that's the sort of strategy that we're going at here. Okay, so next page 3. And so they will take a lot of paper. Oh, here they go. They are telling you the steps now. First, get a 1 at the top, get zeros below it. Then we go to the second column, we get the 1 and we get the zeros below it. And then we go over, we get the 1 here. And then you're done. And if you do this, right, you should have your final variable solved for. So when we did x's and y's, we had the y solved for if it was in this format. Here, y, and now we're going to have a third variable called z. And now our z will be solved for. And so we're not going to talk about it in this section, but we are talking about 3 variables. And so if we want to graph these things, we have to start graphing in 3 space. It becomes a little more challenging than graphing in 2 space. We have to start drawing in and out of the paper, and it's a little more complicated. And I'm not even trying to go into 4 space. I don't know. To be honest, I don't even know that much. You have to go watch those Sagan videos. So we want to do Gauss-Jordan elimination. We want to put it in that row echelon form. So the first thing is to convert the system of equations to a coefficient or an augmented coefficient matrix. And so we want to put these coefficients in. So maybe one thing to note is if we don't see a coefficient, I'm not even sure if that was an issue up until now. Oh, yeah, we did that in this first one, right? That was confusing you earlier. I hope that wasn't a point of confusion, but if it was, we can always throw 1 if we don't see a coefficient in there. That's kind of like one of those things. You have to start seeing things that aren't there if you want to be a mathematician. I don't know what to tell you. Start your mathematic hallucinations now. I don't know. So start seeing things that aren't there. See the ones in front of the variables. Start seeing the zeros if there's no variable there, right? Things like that. Plus 0 doesn't do anything, right? Multiplying by 1 doesn't do anything. If we want to put exponents on there, we have to see 1 exponents on there that aren't on there. So there's a lot of things that when you do enough math, you get well adjusted to them, and you don't even realize you're doing them sometimes, I think. So I got to slow down a little bit and make sure I'm showing what my thought process is. And so let's plug this in. So also maybe to note is that we are taking the negative signs off of it. And so I've kind of said this before, but sometimes I don't even like to look at things like subtraction. I like to look at things like plus and negative, right? My mind just kind of automatically snaps to that sort of thing. Okay, so the first goal is to get a 1 in the upper left-hand corner. So if we want to get a 1 in the upper left-hand corner, there are a few ways to do it, right? But and there's a few valid ways to do it. The way I went about doing it, and I think this might be the quickest way to get the 1 up there, is just to swap these 2 rows. So I'm going to swap row 1 and row 2. And a quick note, we wrote these augmented matrices out. A quick note about these augmented matrices. You may or may not see this line here for the equal sign. So if you're doing this in your calculator is not going to have that bar there. Okay. And it's okay. You don't have to write it. I'll probably end up dropping it at some point, to be honest. It's a line. It's not a lot of work to draw a line. So if it helps you, go ahead, go for it. If it doesn't help you, you can drop it. It's fine. So swap row 1, row 2. I did that. So I got a 1 in the upper left-hand corner. The next thing is I want to get zeros below it. So I want to get a 0 here. I want to get a 0 here. So if I look at row 2, that is a -3. I'm thinking, what do I have to add to -3 to get to 0? So I have to add a +3. I want to do 3 times 0, and I want to add that to row 2. I want to do 3 times row 1 and add it to row 2. So 3 times 1, add it to -3. That's going to be 0 I was looking for. The next thing I'm going to do 3 times a -2 is a -6. I'm going to add -6 plus 1 is going to give me a. The next thing I'm doing is 3 times a -3 is a -9. -9 plus 2 is going to be a -7. And the last one here is 3 times 9 is going to give me 27 plus 8. Okay, so now I'm looking at this thing. First thing I want to do is get a 1 up here, get a 0 below that. The next thing I want to do is get a 0 right here. So this thing is a +2. So in order to make this thing 0, what do I have to add to +2 to make it 0? So the thing I have to add to +2 is -2. So I want to do -1, add this to row 3. Okay. So I'm looking at this thing. The first 2 rows are staying the same. So 1, -2, -3, and 9, and 0, -5. So I did say it uses a lot of paper, but one of the good things is it's just like you're writing the same thing over and over again for a lot of the stuff. So I know you might want to skip some steps or something, but writing these things out really does help. So -2 row 1. So -2 plus 2 is going to give me 0. -2 times a -2 is a +4. 4 minus 2 is going to give me 2. -2 and a -3 is a +6. 6 plus 1 is going to give me 7. And last, -2 by 9 is a -18. -18 and -17 is a -35. Okay. Now we're at this matrix. So we got a 1. We got zeros below it. The next step, if we want to move over, and we don't really care what's right here, we want to look right here. We want to get that 1 in the diagonal. So we have to do something here. So we have a -5. If I want to make that a +1, you could think about it as division, but we're doing everything as multiplication here. So it'd be a -1/5 that I'd have to do. So minus 1/5, and I have to multiply that by row 2. So everything else, row 1 and row 3 are going to stay the same. This thing is going to get multiplied by negative 1/5. So minus 1/5, this is going to give me the positive 1. Minus 1/5 by 7, this is like 7 over 1. So this is going to give me positive 7/5. 35, I'm going to divide that by minus 5. That's going to give me minus 7. And the last line stays the same, 0, 2, 7, and what, minus 35? That's what we got. So the process, we're going back through this, we're looking at this, we got to the step, we got a 1 here was the last thing we did. So we got a 1, we get the zeros, we get a 1. The next step is to get the 0 here. So this is getting a little nastier, but we're getting towards the end, so it will tend to do that probably a little bit. So we want to do something, add to a minus 2 that's going to make 0. So what do we add to a minus 2 to make 0? We add a negative 2. So negative 2 times row 2, and we're going to add that to row 3. So everything else is staying the same. 1 minus 2 minus 3. We're skipping with the 9. 0, 1, 7/5, and minus 7. And now we're doing minus 2 times 1. Ooh, let me throw this 0 down. Okay, that 0 is coming down. We're doing minus, well, I guess I could do it here, right? Minus 2 times 0 plus 0 is going to give me 0 here. Minus 2 times 1 plus 2 is going to give me 0 here. Now we're going minus 2 times 7/5, so that's minus 14/5 plus 7. So I'm not going to write this all out, but we're adding and subtracting fractions. You should be finding a common denominator. And if I'm being honest, if you're using a calculator to figure out this fraction right here, I'm not gonna care too much. You're doing all this other work. If you want to use a calculator to figure out what minus 14/5 plus 7 will give you what, 21/5. Yeah, I won't fault you for that. There's a lot of other work that's happening here. This last thing, last but not least, minus 2 times row 2 is going to give me positive 14, and I want to add that to minus 35. So that's like 14 minus 35. This thing should be giving me a minus 21, and it's getting a little nastier with each step, but we're almost there. Like one more step, I believe. We got a 1. We got our zeros below it. We got a 1. We got our zeros below it. Last but not least, we move over another column. We want to get the 1s in the diagonals. We want to get a 1 here. So kind of looks silly, but if we want to get a 1 here, the thing we got to multiply by is called the reciprocal. That looks like 5 over 21, and we're going to multiply that by row 3. And I wrote it really big because I'm excited. We're almost at the end. So 1 minus 2 minus 3 is 9, and 0, 1, 7/5 is giving me a minus 7, and 0, 0, 5 over 21 times 20 over 5 is the one I'm talking about. And I'm going to divide what, minus 21 by 21, that's going to be 1, and this is going to give me a minus 5. Okay, so we have done our Gauss-Jordan elimination. We have put this in row echelon form. And we're still not quite through with this thing. So we have to go back and reinterpret it. We have to give them a Y, Z. So I'm going to start, and I think I'm going to interpret things maybe in reverse order. So this last thing gives me a really nice thing that looks like Z equals a minus 5. So I have my Z there. This next one looks like y plus 7. So I know z is a minus 5. This looks like what? Y minus 7 equals a minus 7. So when I add 7, this is only going to mean y equals, move it up a little bit, 0. And the last equation that I had way up here, x minus 2y minus 3z equals 9. And so I know my z is a minus 5. I know my y is 0. I can fill this in. Y is 0. All right. Minus 8 times a minus 5 is equal to 9. So this is why you do math in pencil. Sorry. This is why you don't do math in pen. This is why you do math in pencil. Do as I say, not as I do. So x plus 15 is equal to 9, I believe is what this is giving you. So we're going to subtract 15 from both sides, and this is x equals a minus 6. And so, if you got this, if you did all this work and you got these solutions, personally, if I was grading this assignment, which I don't believe I am, but if I was grading this assignment, I would probably give you like full credit. You did all this work, X, Y, Z, you got the correct solution. And hopefully you go back in and you check them. So go back in, plug in X, Y, Z, and see if, throw that paper. See if they work for these three equations, right? Okay. So they absolutely should form a true statement with statements. But if I really don't want just X, Y, and Z like that. I want them as a triple. So when we had two variables, we had ordered pairs. When we have three variables, we have something called an ordered triple. It's three numbers looking like X, comma, Y, comma, Z. And so when we put that together, this is a minus 6, this is 0. And the last thing over here is a minus 5. And so it's in the order of X, Y, Z. It's an ordered triple. Okay. So, this is where you're going to have to do some work. You're going to have to do these and do a few of these. And it's going to require you to write a few pages of numbers. Not sure what else to tell you, but this section is going to require you to practice these things. This is not something that like you're just born naturally good at. I don't know anybody that just like knows how to do these things right off the bat. The other thing with this is if you mess up in one spot, you kind of end up messing up in subsequent spots. So it's kind of a pain in the butt to get something wrong. It's really easy to go awry, right? It's really easy to get stuff wrong. It's not hard to get it right, but it's really easy to make a misstep. And when you make a misstep, it ends up messing up a lot of things subsequently. And so these things can get a bit annoying. Like I'm not going to say like that's not an annoyance, right? That certainly is. But I think it's doable, right? I don't think I'm asking you to do anything too crazy. It's a little bit of a work, but it's doable. Okay, so we have basically two more problems that they want us to put into matrices, and they want us to solve these using the Gauss-Jordan elimination, putting these into the row echelon form, right? So the first step to these is putting them into a matrix. So let's go about 4. I want to write a matrix of 4. Like this, I'm pulling the X. Y to the equals. Okay. And as I was saying, there are a few ways you can go about solving this. There's not like one tried and true way of like Gauss-Jordan elimination, right? But the general approach of getting the ones and zeros is the general approach you want to go about. But there are multiple ways to do that sometimes. The way I went about it is if I want to get a 1 up here, this bottom row has 1s, and so the first thing I did was swap row 1 and row 2. Row 3, sorry. If I swap row 1 and row 3, that looks like 1, 1, 1, 5, minus 1, 2, minus 1, 10. That doesn't change. Now I'm doing the top one down here, 2, minus 1, 3, and a minus 3. Here we go. So swapping them 2. I swap row 1 and row 3. Got my 1 up here. Next thing I need to do is get a 1 down here. This one, I did this all in one step, I believe. I warned you not to do things in multiple steps, and then I did them in multiple steps in my notes. So I know I'm probably a little hypocritical, but here we go. If I want to do row 1 and row 3, my row 1 is not going to change. My row 1 is there. It is the row I want there. It's got the 1 in the upper corner. If I want to do row 1 and row 3, that's going to give me 0. That's going to give me 3. That's going to give me 0. That's going to give me 15. And now I want to make a 0 here. I want to add to 2 something that will make it 0. So minus 2, row 1. Whew. I wrote the wrong row number. This should be row 2. Row 1 plus row 2 was what I was doing. Sorry. And that took the place of row 2. Minus 2 row 1 plus this one is the row 3. Minus 2 plus 2 is 0. Minus 2 and a minus 1 is going to give me minus 3. Minus 2 and positive 3 is going to give me 1. Minus 10 and minus 3 is a minus 13. That's a horribly drawn arrow there. Scribble scrabble. Okay. Now what does this look like? I got my 1. I got my zeros below it. The next thing, I'm going diagonally. I want to get my 1 here. Okay. I have to divide everything by 3. Multiply everything by 3. If I do 1 row 2, do 1 on 1, actually I got 5. Do 1/3 this one, 1, 0. 15 divided by 3 is going to give me 5. And I have this one is still the same, 0, minus 3, 1, and minus 13. Okay. Now recap, I'm doing the Gauss-Jordan elimination. Got my 1, got my zeros, go diagonal, got my 1, gotta get my zeros. So, kind of silly, but I have to go back. I have to go multiply row 2 by 3. So 3 times row 2 plus row 3 is what I want to do. Okay. So I'm looking at this thing. If you want, it is a little tricky. You could probably just go back up to this thing and add these two. 0 and 0 is going to give us 0. So everything else is staying the same, so I guess I can go ahead and write that down. 1, 1, 1, 5, 0, 1, 0, 5. This last row is the only thing that we're doing here, right? So if you want to go back and look up this one, you can. 0 and 0 is going to give you 0. 3 and a minus 3 is going to give you 0. 0 and 1 is going to give you 1. 15 and 13 is going to give you 2. That's a bit of a cheap trick, but it worked. 3 times 1 is going to give you 3 minus 3 is going to give you 0. You could also do it here. 3 times 0 plus 1 is going to give you 1. 3 times 5 is 15 minus 13 is 2, right? Same thing. Now we're looking at this. Oh, so close, but not quite there. So this is x, this is y, this is my z. So I have this thing. I did my Gauss-Jordan elimination, got it in row echelon form. Now I got to go back and do some back solving. So I tend to look at things, if we look backwards, this last one gives me z equals 2. This one gives me y equals 5. This one gives me x plus y plus z equals 5. So it did nothing to that equation. That's the same equation we had in the original. Okay. But look at this. This should be pretty easy to solve for the remaining variable of x. So if we do x plus what? 5 is first, and then 2 equals 5. So x plus 7 equals 5. We're going to subtract 7, so x is a minus 2. Again, if you got this far, I would be pretty happy if you got this far in this section. By the next section, you should really start picking these things up and going, here's my x, here's my y, and here's my z, right? That's what my solution looks like. It looks like x, y, z. It looks like a point in 3 space is what this is. It has an x coordinate, has a y coordinate, and it has a z coordinate. Okay, so we did a lot of work. If you need to pause and rewind or do something crazy, you got the advantage of the technology to help you understand this. So hopefully that will come to your advantage. So the next thing, I see x's and z's, I see y's and z's, I see x's and y's. So I have x's, I have y's, and I have z's, but they're not all there all the time. So I want to rewrite this. I want to rewrite this with x's and y's and z's. So if I don't see it, this should be minus z equals y minus 3. There's a few ways to do this, but I'm just going to go ahead and fill it in. I have no y's, I have 0 y's. So 3x, this is 0 y's, this is minus 1z, if I want to think about it, a cute little 1z, equals minus 3. This next one looks like no x's, but I have 5 y's, and I have a positive 2z and a minus 6 on the other side. And this last one is what? 4x plus 3y, but I don't have any z's. So if I do it this and I write it out like this with the 0 coefficients, it might be a little bit easier to go throw this thing into a matrix. So 3, 0, minus 1, I did a little bar, I do a 3, 0, 5, 2, and this is a minus 6, and 4, 3, 0, and it gives me a minus 8. If you can look at this thing and throw it straight into the matrix, that's fine as well. If you want to write this middle step out and it helps you, go for it, right? Personally, I would probably maybe write that out. I don't know. That's my x's, that's my y's, that's my z. Okay, so I'm looking at this thing. I want to do row reduced echelon form. Not row reduced, sorry. We're just doing row echelon form. So what's the first thing I want to do? There's a few things you can do, but I think the first thing I did is I want to make this a 1. I got to divide everything in this by 3. So 1/3 R1 was the first thing I did. So it looks like 1, 0. I'm going to start getting fractions. Oh no. minus 1. So 0, 5, 2, minus 6, 4, 3, 0, minus 8. So I'm looking at this thing. I want to do row echelon form. I got my 1. I got my 0. Keep going. I got to get a 0 here. So if I get a 0 there, how do I do that? I have to add minus 4 to this 4. So minus 4 by row 1 plus row 3 is going to give me my new row 3. So row 1 and 2 are going to stay the same. 0, 1, minus 1/3. Or 1, 0, minus 1/3, sorry. Minus 1, 0, 5, 2, minus 6. And this is the one I'm doing now. Minus 4 times this 1 minus 4 plus 4 is going to give me the 0. Minus 4 times 0 is nothing. And then I add 3 is going to give me 3. Minus 4 times 1/3 gives me 4/3. I add it to 0, that's going to give me 4/3. And the last thing here, it says minus 4 times 1 is going to give me positive 4. I add that to a minus 8. That is going to drop it back down to a minus 4. And you can probably hear me flipping my notes. I am definitely checking my solutions to these things. Like I said, if you mess up early in this problem, it messes up like a lot of things subsequently, right? And so I want to acknowledge if you have frustration, it's valid frustration, right? But we still need to do this, and practice makes things better, right? I don't want to say practice makes perfect. And I always had to, my band director always goes, perfect practice makes perfect, right? He always had to specify. But anyway, a little bit of a tangent. Let's look back at what we were doing here. We got our 1s, we got our 0s below it. We were successful in getting this first column. We got our first column. Let's move to this next one. We want to get the 1 in the diagonal first. Okay, so 5, to get 5 to 1, we need to multiply 5 by 1/5. So we're doing 1/5 row 2, so my first row stays the same. This thing gets divided by 5. 5 divided by 5 is 1. This 2 divided by 5 is 2/5. Minus 6 divided by 5 is a minus 6/5. So it's getting more and more fractiony, but hopefully we're getting more and more towards the end. So 1/5 row 2. 1, we got the 0s, we got the 1, we need to get 0s here. So now it's getting a little messier. But in order to add something to 3, it's going to make 0, we need a minus 3. So we do minus 3 by row, nope, not row 1, row 2, and we're going to add that to row 3. Row 1 is absolutely untouched. We're not even messing with that guy. We're doing minus 3 here. So 0 and 0. And if you set it up right, your 0s should kind of stay 0. So row 2 is staying the same. So I should write that down already. So let's do that. Here we go. 0 and 0 should give you the 0 here. So minus 3 row 2. Give me minus 3 plus 3 will give me 0 here. Minus 3 is a minus 6/5 plus 4/3. So doing some work, minus 6/5 plus 4/3, you're going to have to convert, find common denominators, but it should give you 2/15. Now I'm going minus 3 times 6/5 is going to give me a positive 18/5, and I'm going to add minus 4 to that. So that should give me a minus 2/5. So you'll have to convert to a common denominator. Or if you have some kind of technology, I don't really mind using it on this like one little step. It's not the crux of this like lesson, right? Being able to add and subtract fractions. So I don't want to spend a lot of time like trying to do that. you should technically know how to do it already. If you don't, you should definitely be practicing it, right? Because it's going to come up and it's going to come up again, and at some point it's going to catch you, and it'll probably catch you enough times to where it's not going to work in your benefit. So one more tangent before I go and figure out this last thing. So 1, got the zeros below it, got the 1, got the zeros below it. We want to get the 1 here. So it's a little weird, but the reciprocal of this is 15 halves, right? So if we 15 halves everything in row 3, row 1 stays the same. Let's go ahead and copy that down. 1 2/5. Row 2 stays the same. And we have 15 over 2, row 3, 0, 0. This is the 1 I'm looking for. We can do some cross multiplying, but this is like 15 divided by 5 is what it's going to end up being with a negative, so I believe it's a -3. We are almost there. Almost there. So, going back, this is my x, this is my y, this is my z. So going back and solving this, the last thing is giving me z equals a -3. The next thing is giving me y plus 2/5 z. 2/5 z equals a -6/5. And so if I do y plus 2/5, and my z is a -3, this is y minus 6/5 equals a -6/5. And so this one is giving me y equals 0. And the last thing we have here looks like x minus 1/3 z equals a -1. X minus 1/3 z equals a -1. We know that z is, from the previous solution, z is a -3. So what does this say? X, and now this is going to be plus 1 is equal to -1. So I believe x, when we subtract 1, is going to end up being a -2. So going back, found our x, we found our y, we found our z. If we put them all together, that's a -2, 0, and a what? -3. All right. All right, so that is the end of the introduction to matrices. We will continue this lesson next time and talk a little bit more about matrices. And I think it'll be a little less work next time. So if this is scaring you away, come back next time, right? But definitely come to this class, right? Because you do need to do the work. You do need to put like in the handwork to get these things done on your own. I don't know how to say this nicely, but you're not gonna learn this just looking, right? You got to get some practice in there. Get it down and dirty. Okay, so that's it. See you in class.